Welcome to an overview discussion and demonstration of the Manufacturing Execution System from Delmiaworks. Delmiaworks understands your money is made on the shop floor, and the difference between an efficiently run facility and one that isn't can be drastic.
Not only is it a function of time and money, but also overall customer satisfaction with on-time delivery of quality products.
Delmiaworks has developed a manufacturing execution system that provides real-time feedback of what is happening in the plant at each work center.
These tools are designed to collect the data and feedback for users, which allows them to make proactive decisions that affect the organization.
Real-time machine monitoring from Delmiaworks is available in two versions: real-time production monitoring and real-time process monitoring. Delmiaworks provides a real-time production monitoring screen that allows users to drill into the details of the presented information.
For example, from this screen, users can see things like what's running on the work center, parts to go and hours to go, standard cycle time information, last cycle, and average cycle. Users can also view quality issues that are outstanding for this item, hours to go or parts to go for in-process inspection, and other types of information. Color coding is used here, indicating to users how well a machine is running for the given part that is being run. For example, machine number 1 is producing a volume cup. You'll notice that most of the line is colored in black. This is because the difference between the standard and average cycle time from the last 50 cycles is significant enough to notify the user. This black bar indicates that the given machine is running quite a bit faster than what the standard specification may be. The second work center is in green, which indicates that machine is running within a standard threshold. Here we see a standard cycle of 16 seconds with an average cycle of 16.21, which is well within range. The third work center is red, indicating that work center is running slower than what is expected, 10 seconds versus 11.14. User-defined parameters allow the system to use desired figures that the system will then use to determine how well work centers are running. Machines marked with yellow are those that are currently in a down condition, and when a machine is in a down condition, the operators or techs on the floor can diagnose the reason for the unexpected downtime for the given work center. Users can drill into the details on this screen to view work center information. This screen displays the last 50 cycles, including uptime, downtime, as well as the real-time OEE factors that are being calculated for every cycle that runs on the given machine.
Delmiaworks real-time process monitoring has the ability to communicate directly with the PLCs that are connected directly to equipment on the shop floor.
The system then uses this generated data to compare against user-defined parameters and track jobs as they are running in real time.
For example, we are tracking machine number 1 and have 3 parameters that the PLC is feeding back to the Delmiaworks system: oil pressure, spindle speed, and tool temperature.
This is a very small sample set. In reality, these could include hundreds, if not thousands, of data elements that are being pulled from the PLC. In this case, for oil pressure, we've set a lower and an upper threshold with a target parameter. The same has been set for both the spindle speeds and also with the tool temperature. We can then track the activity on the machine in real time, and the PLCs will generate live data points to view and analyze. Should the temperature of the tool fall below the lower threshold of 300 or go above the 500 mark, the system will trigger an alarm. This gives shop floor employees a chance to immediately address the issue at hand. The system then takes the real-time manufacturing data and presents it in a readable format in intuitive formats. All of the data is stored in a historian database, which then gives users the ability to look at archived production runs, a particular shift, a particular time during a shift, a particular manufacturing number, a particular item number, or even a particular lot number.
As a part of the MES solution, Delmiaworks has also provided the ability to interact with the operators out on the floor.
This screen represents what an operator might see. As we saw before on our example machine number 1, the system is color coding the run as black, meaning the work center is running faster than what is expected. It also shows this machine has been running its entire shift without any downtime. It has about 10.5 hours to go. We can see the number of parts remaining in this cycle, and so on. Users can also report rejects directly online, and since this is a touchscreen, the system allows the operator to report rejects with a tap of their finger. This gives users the power to immediately quarantine the rejects while sending a message to quality indicating the parts must be put under extra scrutiny once they have been received. The system also uses the reject information to add both parts that must be produced as well as the time needed to produce them due to the offset created by the bad parts. This ensures that the work center has completed producing the correct number of good parts by the time the run is complete, regardless of any rejects that may have been reported from the beginning. The system also allows users to quickly reach vital documentation. They can pull up work instructions and part drawings, quality alerts, any information a user would need as an operator. Even things like videos can be attached, such as this one that shows how boxes should be stacked on a pallet. All these elements are components of the embedded document control system, which gives users control over the documents. This also includes settings for determining who can access documents, who can change them, and then the electronic workflow that allows users to trigger a collaboration effort where a document is changed and checked in. The system maintains all revisions of documents and allows users to revise those documents and push the released revisions out to every instance that might exist within the system. This eliminates the need to keep physical binders and replace old sheets when a document has been updated. Finally, the system can present to the operators or the quality techs on the shop floor directly the ability to perform inspections on the shop floor. If users have equipment that are part of the inline process, the system can pull the data directly from that equipment. Here you will notice that I've actually got some simple corrective action. I've got 14 MRBs, or non-conformances, that must be reviewed, and I've actually got a PPAP for this item. We can easily view the details for these items and find where exactly each of these items are in their individual processes. Next, we can see the inspections that must be completed. Because the inspections in this window are user-defined, the system shows users which inspections the organization has determined must be completed for the given part. In this example, we are doing an hourly in-process inspection. When this is selected, the system presents the inspection set that must be completed, asking the user for the device information that's being used. This information is tied directly to our gauging device tracking system, which allows a user to track all the calibrations, gauge on R&Rs, case studies, and those types of things. If a user selects a gauge that is out of calibration, they will receive an error message saying the device should not be used for the inspection. For the inspection itself, users can record the actual results of the inspection. Again, users can reference attached photos or videos that can provide clarification on the ways in which the inspections are to be conducted. When digital measuring devices are used, they can transmit their results directly to the system using USB, serial, or other built-in ports. The system will then provide immediate feedback if the measurements are out of spec with the part's bill of material. In our example, the height should be between 45 and 51. Since our measurement was 44, the system flags the measurement as out of spec, and it allows the user to leave a comment about this measurement as well.
The Delmiaworks MES solution provides all the tools necessary for our customers to get in front of situations before they run a lot of bad parts to make sure that we're running efficiently as possible out on the shop floor. It also generates invaluable manufacturing data that can be used on the top floor to make educated decisions affecting the operation as a whole. Thank you for taking the time to watch our demonstration of the Delmiaworks MES system. If you would like more information on the products and services from Delmiaworks, please visit 3ds.com/Delmiaworks.